right. Okay, will we get started? All good with you, John? Are we good to go? Awesome. All right. Thank you very much, everyone. This is super exciting. This is the first time we've done this. We've been growing our SENTRY team, developing our product over nearly 8 years now. And I guess 8 years later, we have the capacity to communicate some of our favorite projects. And we're really, really excited with the work we've accomplished this year. So we're gonna walk through some of our top 5 projects, smart water projects for 2020. Okay, so in terms of, I think, you know, we're aiming for maybe 35, 40 minutes, maybe nice and short, to the point. What I'm going to do first for everyone is I'm going to introduce just SENTRY briefly for everyone, just to make sure that we're all on the same page. If you've been on an intro SENTRY webinar, some of this material will be familiar to you initially. And then after that, we're gonna basically, myself and the client managers for each of our top 5 clients, our top 5 projects, we're gonna walk through some of those projects. Okay, so let me get started, and I will introduce the SENTRY platform. Okay. So that's okay. Here we go. All right. So, what is the problem statement that we're trying to solve with SENTRY? Wastewater treatment, biological treatment of wastewater. It is a job that I think has been undervalued and is undervalued. We understand that wastewater conditions coming into a wastewater treatment plant are always changing. So whether it's diurnal trends of organic load coming into a plant, whether it's industry discharging big slugs of BOD or COD, you know, not always at the same time, whether it's industry disposing and discharging acutely toxic materials into wastewater collection systems, you know, all of this wastewater change comes down the pipe and gets to a biological wastewater treatment plant. And downstream of that, you have an operator that somehow has to understand this change, predict this change, and operate its facility to ensure that the effluent leaving its plant is of the desired target or quality. So we also know that the tools these operators have to actually understand what's happening in their biological reactors are not good enough. So, you know, I've just put 2 images up here. You can see what a traditional, you know, light-based sensor might look like if it's deployed in a wastewater environment for not too long a period. And you can only imagine that if you're trying to send a light signal through a nice clean glass slide and you have biofilm growing all over it, soon enough that signal is going to drift and it's not going to give you reliable data. And then also the chap on the bottom here, he definitely doesn't have the best job in the world, where he has to manually go to a wastewater stream every morning at 9 o'clock usually and take a grab sample, and that would then be sent for analysis, and he might get one single data point back 3 or 4 days later, perhaps. Again, that's not going to help anyone to understand the process and how it's being impacted in real time by changing conditions. So at SENTRY, what we developed was a very different way of understanding biological change, but more importantly, a very different way of understanding how wastewater conditions impact biology and how that impacts the wastewater treatment process. So why is our technology different? So if you can see here at the end of the sensor, what we have are 2 conductive surfaces. These 2 surfaces, we apply a small voltage on those 2 surfaces, and naturally occurring bacteria that are already present in the wastewater streams will simply grow on these surfaces and then use that surface as a terminal electron acceptor. So just like most biology in a wastewater treatment plant, they're all fighting for BOD. They're all fighting for carbon, for energy. The same here. This is, you know, a representative surface. It's just sitting in your wastewater stream. Biofilm grows here, and the only key difference is that the biofilm on this surface isn't using oxygen as an electron acceptor if it was an aerobic environment. It isn't using CO2 as an electron acceptor if it was an anaerobic environment. It's using the surface. It just deposits electrons, and then we measure the flow of those electrons. So in a very, very real sense, what we're doing is we're digitizing biological activity. And once we do that, it's very nice for us to be able to display that information in a simple visual format for operators to see actually what's happening. So you have a biological reactor, it's being powered by biomass, and we will profile for you and show you exactly how that's being impacted in the wastewater environment. Okay, so just because we have a technology that's kind of cool and works really well in wastewater environments and sends us really interesting information, that's just step one. The real important thing is that we can actually demonstrate that this has value for operations. So when we started with SENTRY, when we started with commercial deployment 3 years ago, we were pretty much focused down here, bottom left-hand corner, on supporting operators of anaerobic digesters. What we didn't do at the time, though, was just say, this is the only way to use our data, and we work with anaerobic digesters only. What we said was, in all of our conversations with potential customers was, this is a platform technology, this is what it does. Now, can you share with us the problem that you're most interested in and that you think this could help you with? And when we get into our top 5 projects, you'll actually see that, because there's a recurring pattern of us basically presenting the technology and asking our clients, where can this help you? And it's really from those questions that we've got some of our most exciting work. So after digesters, our most typical installation actually for most of our municipal clients and industrial clients actually is to get sensors in the front end of their wastewater treatment plant, so in these primary clarifiers. And then after that, our customers typically go one of two ways. If toxicity is the key thing that they're worried about or being impacted by, they'll go into the collection system and try and target those people and try and identify them more specifically. But if it's process optimization is more their goal, they will move downstream in the process. So they will look towards aeration optimization, perhaps, maybe a feed-forward signal from the clarifier, helping operators understand how much demand the biology are going to want for oxygen, or whether it's further downstream again, maybe it's BNR, carbon dosing, understanding supplemental carbon dosing, or whether it's biophosphorus removal and understanding when your biomass has carbon, when it doesn't have carbon, and then all the way down to effluent monitoring. So, and the whole time, what we're providing is physical sensors that are just placed into the wastewater. You leave them alone. They're biofilm based. So we specifically asked, don't clean the sensors. We want people to inspect them every 3 months, but we don't want you, scrubbing the surface or cleaning the surface. And then that information is sent to the cloud, to a nice, clean, simple online dashboard, but also on-site, we can tie it via 4to20 into your on-site SCADA. All right. So that's the technology intro. What I will say, we've been deploying systems now over 3 years commercially. We're very excited with the progress in 2020. Providing an ability to remote monitor your biological process in a simple way with a low maintenance sensor, I think it has there's lots of interest out there for those types of tools. So we're very excited. A lot of our work is North America. The UK is a great spot for us. And more recently, Singapore and Southeast Asia is becoming really exciting. So the first thing we're going to do, because we do this with all of our customers, so we're going to do it with everyone here, is we're going to ask a question. So this is going to be a little bit interactive. So relaunch polling. Okay, so I have launched a poll. I hope everyone can see it. So what I'm going to get people to click on here is, which problem statements are you most interested in? So I've just introduced the SENTRY platform at a high level. And what I'm hoping for, just like we do when we go meet our customers or when we go present our technology, is that everyone here can just comment briefly, click on the problem statements that are most of interest to you at the start. We will come back at the end of this webinar, at the very end, and we might see how that's changed. We'll ask a similar question, similar but different, so we'll see how that shifts. Okay, fantastic. I'm going to keep the polling open for another 15 seconds. Most people have commented, but keep it up. We're almost there. This is great. It's across the board as well. So we're getting a lot of anaerobic digestion. We're getting a lot of aeration optimization, influent load, or okay, awesome. Okay, fantastic. Okay, I'm going to end the polling. I'm going to end the polling now, and I'm going to share the results. Okay, can everyone see that? Anaerobic digestion looks like it's on top with aeration optimization or influent organic load monitoring. Okay, this is great. That's really insightful. Okay, fantastic. Okay. So before we get into the top 5, there are 2 specific applications or installations that I just want to touch on briefly because they've been just remarkably insightful for us over the last 2 years. So the first one I want to talk to is work that we're doing with EBS. They're based out of Louisiana. So the pulp and paper industry, coming into my background isn't pulp and paper. My background, I guess, would be anaerobic digestion, industrial, and then moving to municipal. When we heard of the pulp and paper industry and understood the toxicity type issues with some of their effluent, it became clear that yes, SENTRY could be very valuable. We are working with EBS in Louisiana, just a remarkable group of water professionals who really understand the pulp and paper industry. When we proposed SENTRY to them, they came to us and said, you know what, we really need to understand, and if we can identify when these black liquor spills are coming from the pulp and paper process and hitting the downstream wastewater treatment infrastructure, if we can work together and identify those events in real time and help operators understand if those events are about to happen and save monies related to those, that would be massively, insightful and valuable. So, those types of discharge events can cost, significant amounts, both in terms of lost chemicals, but also in terms of, additional requirements for wastewater treatment downstream. So what we did is we worked with EBS first at the bench scale. They created their own pilot scale simulated wastewater treatment plant, and they dosed in the black liquor type material, and we could, identify that instantly. So as soon as that black liquor reaches the wastewater environment, we would find that big spike. So you can see here, that would be a typical response curve for a black liquor discharge. But again, the ability to identify those events in real time, and we're now working with EBS across the US with different pulp and paper clients, helping them to understand these events, identify when they're happening and quantify the impact on their process. So that's just one I wanted to bring to people's attention because it's a great reference of identifying a problem statement and then working through a validation process before we go to commercial deployment. The second one I would like to touch base on. Now, if you've sat through an intro webinar with us, you will definitely be familiar with this data. So this is coming from the town of Montague, the region of Three Rivers. And what I've done here, Bryce Stewart is the client manager for this customer. These sensors have been installed for 3 years. The main reason I bring this up is because these sensors haven't been cleaned in 3 years. So you can see I just at the top here, I've taken the data from last week. So some of the interesting things, we're identifying industrial dischargers. In this case, it's breweries who are discharging slugs of BOD into the collection system. We can pinpoint exactly the time of day and what days they're doing more or less of that type of discharge. So there's really good stakeholder engagement. But also then when there's events like rain infiltration, you can see here on the low end, this was actually Hurricane Teddy as it passed through Prince Edward Island. And you can see how the additional dilution in terms of the incoming wastewater, how that impacts and how that suppresses the activity at the front end of the plant for that 24-hour period. And then also, what we just did, I just pulled back the last 12 months of data from the plant. So this is just a really nice profile from the influence of the facility, and it has that full record. So you can see very clearly over the 12 months that there are seasonal changes. Not everything is the same every day, certainly not every month, not every week at a wastewater treatment plant. And this just profiles 3 years later, how our ability to monitor those wastewater conditions and communicate how it's impacting the process are really valuable. Okay, so with that, so those are the 2 notable mentions. With that, we are going to move forward with the top 5 smart SENTRY deployments of 2020. Okay, fantastic. So the first, what I'm going to do is I'm just going to do the problems, talk a little bit about the end user, and then I'll hand over to the client manager the data and the insights specific to that application. Okay, so number 1, Wessex Water and aeration optimization. So, Wessex Water, we first got introduced to Wessex, our local manufacturer's representative, so a company called QCL, an individual there called Mark Watton. Myself and Mark drove down to Wessex Water. We connected with the chap Ivor Whittle. Ivor Whittle is the process optimization specialist for Wessex Water. And it was literally just like today when we started. We presented the technology 5-6 minutes. This is what it does. This is how it works. What are the problem statements that you have within your organization? What are the treatment facilities where you think this would be a good fit? And instantly, Ivor had a really good candidate for us, and it was a very interesting facility. So it was a wastewater treatment plant that had a lot of traditional municipal wastewater coming in, but also had one key industrial discharger. It was a food production or a food processing type facility. And they were discharging big slugs of BOD and COD, but not always the same quality, not always the same volume, maybe not even always the same time of year. So it was very difficult for Ivor at this facility to understand and basically optimize his own process downstream of that. The other interesting thing about this one is the type of organics that was coming down the pipe was very short, like very sugary type water or waste stream. So not very difficult for a UV type sensor to pick that up. If the organics are too small, if they're sugar based almost, if they're not large complex carbon based compounds, then it's sometimes very difficult for the traditional COD light based sensors to pick it up. So the question we wanted to test with Ivor was, could the SENTRY platform, could a bioelectrode sensor provide an in situ reading before the aeration basins that could provide a feed forward signal to those aeration basins to tell them when to expect additional BOD or additional demand on the biology. And then also as a secondary goal, it was, can we actually profile for Ivor, what's coming into this plant? What are the actual triggers? Can we put some data and metrics behind what's coming in and how it's impacting the process? So I'll just briefly highlight the process here. So we provide the SENTRY system. It's a control panel, and then the sensors were literally lowered into the wastewater. So there's no moving parts. You just let the sensors sit in the wastewater, and they're installed in about 4 hours. And at this site, we do visual inspection of the sensors about every 3 months. And with that, Jack, will I hand it over to you and you can talk about the project?
Yeah, that sounds good. Thanks, Pat. Yeah, and just so you can see a little bit of a PFD on the bottom here, or just the overview of the plant. They're a complicated plant. They have, multiple process streams that they can bounce wastewater through. Primarily, basically, there's a BAF system, biologically activated flooded filter, and a traditional ASB lane and a high purity oxygen lane. And the majority of the industrial stuff, they're trying to push through the high purity oxygen, with the other systems kind of collecting the rest of a little bit of the industrial and a lot of the municipal wastewater. And for them, they were really trying to target, these BAF systems. They're a little abnormal, maybe not super standard for the wastewater industry. Very interesting technology, basically does biological treatment and physical filtration in the same step, so you don't need a secondary clarifier after it. Has a lot of small beads in it that you upflow, water through. So really good piece of equipment. Just, I guess it's very energy intensive, very maintenance intensive. And they have 5 of these systems kind of running simultaneously and trying to figure out when they can bring one offline, or potentially up to 2 offline, is really where they're trying to get to. And the most important part for that is understanding their influent conditions. So it was it's been a really great working with the Wessex team and the QCL team, as Patrick mentioned. Very open to innovation, very much trying to improve their performance at facility. Also, very open-minded. Work with us. Got us some additional extra data, which was very helpful, both in BOD sampling and connected up to that light-based measurement. But you can see, show you some of the results. We're looking in the top left here. You can see some good trending with the BOD data and the MET data. MET being the blue data, and obviously that's a lot. Even with frequent sampling at a facility, even a couple times in a day throughout the day. You still have to fill in the lines between, whereas obviously with the SENTRY signal, you get constant data through that. We did pick up 21 imbalance events. That was over about a 3-month period. That's just a snapshot. A number of those were associated with I&I, but also picking up this industrial discharge that, as Patrick was saying, our sensor responds quite happily to some of these, simple sugar, low chain carbon compounds, where some of the other sensors don't respond well to those. So we were able to kind of keep that detection up. And then one of the interesting things for almost all of our clients, and this is something when you finally get real quality, instantaneous data, is you're pulling a lot of pieces together. For them, we were really able to tell them, what days of the week were the high loads coming in, what time periods of the day. And it's always a bit of a surprise for people. They all have their kind of thoughts on it. And there's obviously industry standard about when you think that's going to happen. But for them, you can see in the bottom left-hand graph, Sunday, they were underloaded. Wednesday, they were kind of higher loaded. Thursday, Saturday, kind of underloaded. And for them, their kind of lowest time period of loading to the system was typically 12 to 3 p.m. On a given day. So this really lets them figure out when are the opportunities for cost savings here. If you go to the next slide there, Pat. And just a little more information. This is about 500,000 pounds per year for energy, requirements. So we're hoping to get a 10 to 20% energy savings through this usage. And you can see in the bottom right a little bit of the data from the optical SENTRY signal and DO sensors. Essentially, spikes up in our data, in the COD and SENTRY data, decreases in DO and vice versa. So you can really see how a slug moving through changes that aeration basin. Thank you, Pat.
Fantastic. Thank you, Jack. Okay. So Wessex is fantastic. So that's one for the aeration optimization people. And then again, looking at that providing that feed forward signal from a location before the aeration basins and being able to inform or help the DO get to its set points more accurately, and maybe providing that early warning for those load changes. Okay, so number 2, the client manager for this one is Dr. Colin Ragish. I'll just speak briefly about Central Marin Sanitation. We work globally, and we work with large utilities that manage lots of wastewater treatment facilities. And the US is interesting because, it's a lot smaller. You have small communities managing their own wastewater infrastructure. California, however, in general, tends to have this culture of innovation that, it manifests itself across a lot of the utilities in California. Central Marin certainly stands out as a smaller utility that's doing amazing work and people who are just thinking ahead. So when we went to visit CMSA, and they're located just across the Bay Bridge from San Francisco. When we went to visit them first, again, we just presented the technology, and they came back to us with, we have these digesters. We know they're underloaded. We would love, and our goal is to process more organics, work with local industry, receive more organics from them, fog, restaurant waste, and we're going to get that into our digesters, and we're going to produce more biogas, and we're going to generate more revenue for our utility. So working with people like that who are thinking about revenue generation and not just cost savings, for us is really, really exciting. But the challenge is, we can just operate our digester normally, and that's fine. But, if we can work with local industry, if we can receive additional organics, if we can generate more biogas, if we can produce more electricity with CHP, then that's a massive bonus for us. The challenge is the risk, if we do that, of potentially causing a system to go sour, or, the system not performing very well and not having downtime in our digester. That would defeat the whole purpose of things. So to get there, to stop that from being an issue, we need better data. We need sensors that are going to tell us in real time when our system is stable, and more importantly, notify us early when our system is going to go into a state of imbalance or potentially move toward that position. So that was the problem statement they posed to us. They have a fantastic pilot scale system set up at the facility, 2 duplicate reactors, and I'm going to hand over to Colin, and he can talk about it.
So hopping right into how we're installed into the system, we're installed on recirculation lines, one on each of the reactors. And installation was quite quick and easy. Once they had the tees installed, we're really looking at two to 3 hours to complete this installation. And they've had quite low maintenance here. So we ask every once in a while, so we're looking every 3 months to visually inspect it. Or if we see really unusual activity here at the site, we'll ask them to pull the sensor out, take a look, and just to verify everything's okay. They have had to clean the sensors a couple times, and this was just a heavy coating of fats, oils, and greases. That can happen. Physical obstructions on any sensor are a problem. Hopefully Pat can flip the slide here. There we go. So we'll hop right in the data. What's really awesome at this site is we have two systems that are operating in parallel with the intention of them being identical. Now, kind of unique here is we see 6 hours of feeding every day. And if you look at that graph, we see the two reactors reacting to this feeding with an increase of activity daily. And then the activity drops off as the feed is consumed. And what's really of interest and of concern at the site is how do we manage feeding of fats, oils, and greases, trying to use it as a value-added feedstock, but we know it can be challenging. And one of these challenging events was shown on May the 9th. Essentially what happened is they started getting feed into the pilot reactors that was much more concentrated, specifically in solids. The solids were about 5 times greater than the typical feed. And what SENTRY denoted right away the first day is that we saw a change in the pattern of activity, and after that we saw increasing activity. So we know something has happened to the biology, and we had a nice stable reactor, so we know there's something to be concerned about and watch out for. And at the site they had a few parameters that they would typically use for imbalance. And the first one to flag of imbalance was 3 days after, and that was volatile acids reaching over 200 milligrams per liter. However, SENTRY was telling us that something had changed 3 days before that, really giving an opportunity to do something. And in these two reactors, we actually found that the volatile acids peaked above 2,000 milligrams per liter. Unfortunately, that meant one of the reactors had to be completely restarted, so cleaned out, restarted from scratch. And the other one, it took about a month to nurture it back to typical conditions. So you can see that SENTRY provides a unique opportunity to avoid these kind of failures. And what we've really found throughout working on different anaerobic digesters is that unfortunately, monitoring is quite data and information poor. And it's a result of a lot of the information we need to collect or want to collect requires manual sampling traditionally. And this is both expensive and time consuming. And these parameters are a delay of what's actually happening in these systems. And this really means that we're always behind that 8 ball a little bit, and our operations are quite reactive. So unique SENTRY, and since we're really looking at the fitness of the biology and the biological process, we're able to provide this advanced warning. In this case, it was as much as 3 days. And we believe that this is a substantial opportunity that will allow us to limit negative impacts so you can maintain your biogas production for sale and also to avoid that potential reactor downtime. So when we're looking at something like the size of CMSA, as Pat said, one of these downtime events that could last for a month, you're looking at a cost exceeding $45,000 to $90,000 or even greater. And so now that we've completed some work on the pilot scale, CMSA has great interest to now install in a full-scale reactor. And so we're doing that work right now. And the whole goal is to avoid these downtime expensive events. And as we go forward, hopefully to also increase what they can produce.
Fantastic, Colin. And I'll just add to that as well. I do think there's a growing demand in North America for co-digestion when it comes to leveraging that additional capacity that municipalities have in their digesters to produce more biogas. So that's fantastic. Okay, number 3, Western Environmental. So this is a lady by the name of Amy Gamache. So Jack Ambler is the client manager, but more importantly, Amy Gamache with Western Environmental is just an amazing person to work with. Not your typical, I would say, manufacturer's rep. We came to Amy, again, introduced the technology. We met Amy at WestTech last year, actually. We sat down with her and we talked about what the technology could do. And immediately she had a new problem statement for us, or a different type of application, one that we hadn't done before. And it was, our problem statement relates to the wastewater collection system. And we can't afford, or it's very awkward for us to put the traditional type sensors or do grab sample analysis from wastewater collection system environments, because they're hard to get to, nobody wants to be going down there, and what we need better sensors, or we certainly need better data that's going to allow us to extract that signal, but do it in a low maintenance way where we don't have to go back down there every other month or every week to clean sensors or take manual samples. So to work with a manufacturer's rep who has the capacity to test something with us, validate it with us, and then introduce it to her client base is remarkable. So that was, the general problem statement was that we have a collection system. We need to be able to more accurately understand where the wastewater and what the wastewater quality is coming from different parts of the collection system. And the key thing here is some of their existing costs were quite prohibitive. So for example, it was costing them up to $100,000 per annum to do manual type analysis at some of those locations. So the question is, could a bioelectrode sensor, could a sensor that's taking that real-time information from the biofilm in those collection systems be a better substitute or surrogate for that information? And could we deploy those systems in the wastewater collection system and provide that real-time signal? So in this case, you know what, Jack, I'll hand this over to you. You were intimately involved in how this was installed. Jack actually traveled for this install, so I'll let you take it from here.
Great, thanks, Pat. Yeah, and just a little bit further on the problem statement, it's just really interesting to start getting into collection systems. I do think that the industry as a whole, there's kind of some low-hanging fruit still in the collection system from a standpoint of really understanding your entire water budget there. Who's sending what? How strong is it? Do you trust what your upstream customers are potentially actually discharging to you? Are they being honest? Are they even aware of what they are discharging? All these types of things are very interesting. One, from just a collection system management, and then obviously, as you move further into the future here, understanding stuff as it comes, even maybe several hours, several days out from your collection system, and when it gets into your system, I think is really important. For this install, installed on the side of a partial flume, you can see it on the right-hand side, just up against the wall there. It was in a flume because that's where they were doing some volume measurements, although we did also get installed with a flow meter at this. So we go to the next slide here, Pat. So yeah, I think there's a lot of really important stuff in the collection system. However, it's very difficult to get in there. It's difficult to get systems in there. It's the worst type of wastewater in the industry, besides some industrial ones. So your material, your equipment needs to be very low in maintenance, and it's very often difficult to get in to even do anything. You might have to shut down a road. You might be entering a hazardous area. So low maintenance is crucial to keep reliable data going here. So just to get into some of the data that we saw at this location, the top left, you can see we were installed in this case, again, next to an optical sensor. Top left, you can see the blue data being the SENTRY response, the yellow data being the optical response. And you can see very well how they line up together, predicting the same type of time periods. So lines up quite well with that data. Interestingly, for this site, we also see time periods where we diverge from that signal, from that light-based sensor. The light one is obviously just an optical effect, whereas ours is actually true biomass response to it. So this was installed in a residential area, and we've been finding some very interesting things that were not expected. So we're seeing the normal day-to-day and week-to-week trends, and we're also seeing time periods where there's something else getting in the system. We're thinking it might be illegal dumping. We've collected some grab samples, this type of work. So there's a lot of interesting stuff that we were seeing just from the normal time periods, and then stuff that wasn't being picked up with other types of technologies. And then on the bottom left here, we just did some comparison. This just to show you, this is a weekly, this is how does it perform through the week, what loading goes through, 3 and 6 months sliced, the yellow and the blue lines here. And you can see quite clearly, time periods that it's high loading, time periods slow loading, and what days of the week. So I think that's it on this one. Yes, and again, maintenance being crucial for these types of installs. It's been in there for over a year, and it's actually only been maintenance one time. So it's just a really important aspect for anything getting inside the collection system.
Absolutely fantastic, Jack. Yeah, exactly. So having something that doesn't need to be cleaned, or something that is more fit for purpose in a wastewater environment, is certainly more appropriate for those locations where it's just too expensive or too prohibitive to keep going back down there. Okay. On to number 4. Now, this one is very different, very unique. I get very excited about this one because this one isn't wastewater. So this is drinking water. Dr. Colin Ragish is the client manager on this one. Again, and this is different because at this stage we went to San Jose Water, we presented. So there's 2 chaps there. There's a chap, Adam Pfeffer, and Shaz Chan are the 2 people that we work with. Just amazing people, and the ability to take what we presented to them as a biofilm-based center or a microbial activity-based center and think a little bit outside the box for themselves and fit it into their specific problem statements was really fantastic. So San Jose Water, microbial activity monitoring. So when it comes to drinking water distribution, the key thing everyone wants to understand is, do I have microbial growth in this distribution system? Now, and how much disinfectant or how much chlorine do I have to add to repress or inhibit microbial growth in the distribution system? So, I mean, the status quo is I'm going to measure chlorine residual and I'm going to use that as my information to appropriately dose disinfectants. But the challenge is what you actually are trying to figure out is, do I have microbial growth? So the question for us and the question for Adam when we presented this was, well, actually, if your sensor can work in these environments, that's the actual information I really need. I really need to understand in real time when microbial growth is occurring or when it's beginning to occur, so that I can be more proactive, whether it's boosting or whether it's disinfecting and maintaining those low biofilm or that low microbial activity in the distribution system. So that was the question. Can a bioelectrode sensor provide that in situ reading, real time, all the time, always on, without any manual sampling? And can we use that to more to inform operators as to when this microbial growth or microbial activity is taking place? Now, with that, Colin, I believe I will hand over to you.
Yeah, so similar to all our other installs and similar to the last one I described at CMSA, we're looking at an installation that was in pipe, and you can see it there as a simply T-junction tapped into their typical piping, and then the sensor inserted. And it really was an afternoon to install it. And we've had some need for some visual inspections, specifically being a new application. We saw some interesting events regarding activity. So we've asked that they take it out and inspect it just to verify and validate what the sensor looks like in this new operation. Now, hopping into this data, the one thing you'll notice quickly is that the activity levels, that's the y-axis, is much lower than the other data we've shown so far today. So typically wastewater, we're looking in the hundreds of MET, and in a system like this, we're looking much less than 1. And again, as Pat said, the whole goal is to minimize microbial activity. And if we can minimize microbial activity, that will minimize the biofilm growth. And so what I've put on this graph is the chlorine residual, total chlorine residual, and that activity measurement. And we see that the chlorine residual is made quite well from March until about mid-April. And we do see some, spikes and decreases in residual, but it's a challenge in any distribution system that's large to maintain that residual consistency. And we do see some spikes in activity when these residuals drop, but early on, those are transient. So not a problem because we return to good control conditions. This all changed in April when there was a little more challenge keeping the residual up higher. And we saw suddenly that our baseline in activity increased a little bit. Not only did it increase, we started to see higher peaks in activity and longer duration of events. So we knew that something had changed biologically. There was more biological activity. So we believe that this one is when we really started to see a biofilm develop in here. And this presents a problem for the system, specifically since San Jose is using chloramines. They know that the development of nitrifying conditions is a problem. So we knew we've developed something, and then in early May there, we started to see a lot of rapid changes in activity. And that's unusual. And that tells us that something's devolving or unstable inside this biology. And it turns out what that appears to have been is one of these nitrification events. So when they get nitrification, they get rapid depletion of the residuals. And sure enough, that's exactly what we saw in this case. So if we move on to the next slide. What we've kind of defined operationally here is that we have really good control of biofilm, and we are able to maintain good residual conditions when we have activity that's below 0.05 MET. So we've placed alarms to start to warn us when this is happening. And if we see consistent spikes or regular spikes in activity over this, it's time to start to pay close attention to residual drops off and maybe start to investigate what is going on. And we know that when we start to see regular spikes above 0.1, we have significant concerns. We probably have an environment that could see a rapid depletion in chlorine. And so it's time to consider preemptive disinfection dosing or boosting. And what's really exciting here is that I think we provide the opportunity to improve our residual management in this last mile problem of disinfectant. And we think we can both increase our effectiveness of boosting, which isn't always effective in some of these situations, and we can also optimize our residual. So we can hopefully lead towards cost savings as well as a better product for the clients.
Fantastic, Colin. And you know, for me, because this is so different, like 95% of what we do has been wastewater, and to begin to move over into clean water. So we have a number of drinking water projects ongoing right now, and you know, watershed groups, so in lakes and areas like that. But the first time, I guess, we saw data showing the inverse correlation between microbial growth and residual, that inverse relationship to me is just amazingly interesting and makes sense. It just makes perfect sense. So it's great when data makes sense and is exciting like that. Okay, so I think I actually gave a sneak peek at this one 2 seconds ago, but number 5. So this is our last top smart SENTRY project of 2020. So this is with United Utilities. Now, I want to say something about UU because we do work globally at this stage, and the UU was the first utility that we worked with that had a really amazing process for working with early stage companies or companies trying to offer new solutions. So Kieran Brocklebank is the lead of innovation over there. You know, I sat down with him maybe 2 years ago now. We sat down, we had a meeting. We looked, you know, I just did the same thing. I presented the SENTRY platform to Kieran, and I said, you know, what are the problem statements that you think, you know, where this might fit? You operate 400 wastewater treatment plants, something like that, 400. And Kieran came back to me with 5 problem statements pretty fast after that. And then pretty soon after that, him and his team, you know, they deployed resources to look at this, but then they developed a really nice process for us to work with them. So, you know, they not only, you know, provided capital or funding to support the work, but more importantly, they provided internal resources and people who would take these on as individual projects. So with UU, they identified 5 different types of problem statements. And this is the one for us that I think when we heard about it, we were like, yeah, this is a really nice one because it's a little bit different, but it's also focusing on value. It's focusing on cost savings, and it's possibly even revenue generation. So in this case, what UU have is they have a large number, over 400 wastewater treatment plants. Each of those plants clearly are producing waste-activated sludge, and it would not be cost-effective to process all of that waste-activated sludge at each of those small facilities. So the question was, can we haul the waste-activated sludge from a number of those facilities to one central location, and can we process it in one central location? But the question was, we need to understand what's going into that centralized wastewater treatment plant already. We need to profile what's going into it, and we need to understand the times of the day or the days of the week where it's underloaded already, so that is the time when we should be adding this additional, in this case, centrate from waste-activated sludge. So that was the problem statement. And Jack Ambler is the client manager for that one. And I will hand it over to Jack.
Thanks, Patrick. Yeah, and just to go a little bit more on the United Utilities, and it was interesting. You know, my background's primarily North American. utilities, which, yeah, like a lot of times get stuck a little bit on their own islands and that they don't have a lot of support, or they might be working, primarily on their systems. It's very interesting with the UU, with the UK model where they have, a small number of private companies having a lot of different systems, but it also makes it for a very interesting, there's a lot of roles that kind of exist in that UU thing for energy efficiency optimization, which are quite important to them. And they're able to kind of get data from all their sites and get it to centralized locations so that people can make actionable items on it. So that whole, certainly there's pros and cons to both method, but it was a very interesting for us to get into that and work with this group and get exposed to a lot of these, data management experts from United Utilities. But yeah, so we were installed, just to tell you, the system installs the primary clarifier, effluent primary settling tank in the UK, and one at the effluent of the facility itself, or effluent of the biological reactors. If you go to the next slide, it actually hasn't been maintenance since the installation so far, but we've been getting really good data at the location, so it hasn't been a requirement. But yeah, so just to talk about the problem a little bit more, we were able to get installed before, baseline the facility before we got a bunch of new material being added. Then we got to be, we were installed during the time periods that they were ramping up that material. So we had a baseline. We already knew, approximately when the high loads were coming from their background state, when they were perhaps underloaded, when there was, extra capacity. Then they started ramping it up. So we could see, all right, this % increase, how much does that affect the influent? How much does that affect the effluent? Is that, is there actually capacity in the system, or are we seeing some of that material, pass through the system? So getting a sensor up the front and at the back end was quite nice for the facility. And then also, as they've started to ramp this down a little bit, as they've experimented on that, we've been able to quantify that and see some of these levels going back down. So yes, I think we were able to see quite an interesting loading pattern for them, understand when they should, and then understand when the problem actually came through, what to do with it. And for them, they're both, they're very simple. They're very interested on energy efficiency. They're very interested just so that's just kilowatt hours produced or used, but also interested on and balancing their electrical stuff around the grid's requirements. So that's been an extra point. And a little bit of extra I&I comes through any of these UK facilities. So it's always interesting for us to take a look at, and compare kind of around globally. I mean, I feel bad for everyone in the UK getting pounded with all the rain, obviously, but it's very interesting for these facilities to see, how much I&I some of these facilities get and how much rain they have to really deal with.
Tom Williams might be able to correct me on this, but I'm not sure if the sun shines too often in Manchester. Awesome.
The sun shines a lot. It's beautiful today. See, it's shining on my face as we speak.
Fantastic, fantastic. Okay, thank you, Jack. Okay, folks, so we have come to the time. So what we're going to do here, instead of, let me just see here. I need to scroll up. Stop sharing results. I'm going to go for a second poll question. I'm going to launch polling. Okay, so I've launched the second poll, folks. So we're not going to ask who is the best project. We're going to ask which one of these do you want to learn more about? Which one is, perhaps most interesting to you? Where are the value statements that you think align more closely with what you guys are trying to accomplish going forward? So if people want to comment on that, and what we can do afterwards as well, people can reach out to myself directly. We can always send notes, but what I will say is we do have, extended case studies developed for most of these. We have webinars that are posted online. We have case studies published on our website. I think we have 15 case studies published on our SENTRY website, SENTRYwatertech.com. So you can reach out to SENTRY Water Tech. You can reach out to myself directly. If you know John Grant, you can reach out to John Grant. Most people in the water industry know John Grant, and if they don't know John Grant, they know Tom Williams. Or they probably know both Tom Williams and John Grant. So you can feel free to reach out to John or Tom, or myself or Jack or Colin, certainly as well. Okay, fantastic. Okay, so we have a few good people, a number of people have commented. Anybody else want to put in there? Okay, 37, perfect. I'm going to end polling, and oh wow, Oh, nice stuff. Okay, I'm going to end polling. Boom. Okay, so I'll share the results. And okay, Wessex water aeration optimization and San Jose water disinfection monitoring. Okay, well, that's really interesting. Okay. All right. So with that, just hold on there 1 second. So this is for everyone. You know, our goal is to just continue to deploy sensors and to get better data in our clients' hands. We understand that the existing data in the industry for understanding biological process is not good enough. To do this, we are completely focused on reducing barriers. So for anyone that wants to, if they have a problem statement, perhaps it aligns with any of the ones we've identified, perhaps it doesn't, perhaps it's something different. Feel free to reach out. We're offering everyone, you know, it's $1,000, so we're only asking for a token payment, and we do a 3-month project. At the end of that 3-month project, you will get a case study or a report that will document, you know, we'll work together on it, whether there's benchmarking, whether you want to identify I&I, whether you identify, you know, toxic shock, industrial loads. We will work with you to develop a value statement that you know, that works for your facility and your operation. So with that, I think unless does anybody, John, Colin, Tom, does anybody want to? Did I leave anything out, or are we good?
Sounds great to me.
Okay. So yeah, anyone who wants to reach out, my email is up there, my cell number is up there. Anybody can call me on my cell as well. Call me direct on my cell. If you have a good project, you can email me or call me. And for all those case studies, you can go to the website. And I think we'll leave it at that. Thank you very much, folks.
Thank you, everybody.
Thanks, everyone. Take care.